Welcome back to the another session of the application of linked list. Last class we are already covered the how to represent the polynomial using the linked list. My previous video I have already explained. I also put the link in the description section so you can go to the video and just understand how we can represent the polynomial by using the linked list so that it is easy to understand how we are going to perform the additional. Polynomials are algebraic expressions that consist of two things. First one are the variables or as well as the coefficient. So it is one of the linked list application. We are already covered how to represent the linked list, how to insert, delete, all operation we are completed. Right now we are going to cover one application of the linked list. So polynomial manipulation is the one of the linked list application. We can perform addition, subtraction, multiplication, but not the division. So today in this video, we are going to cover how to perform the addition of polynomial. So let us take an example here. So polynomial is given. So this is 5x cube minus 2x square plus x minus 3. This is minus 2x cube plus x square plus 5x plus 1. So this is our first polynomial. This is our second polynomial. So whenever we are going to perform the operation, at that time what happened? We have to start from the polynomial 1 and polynomial 2 simultaneously, and we have to make the comparison between the power. If the power is same, then we have to perform the addition. Here the power is same 3. So we perform the addition, that is 5 plus minus 2. Then next we have to move. Here also power is same. So we have to minus 2 plus 1. Then this is the x, this is the x means coefficient is 1, this is the coefficient is 5. So 1 plus 5x plus, this is the power is 0, here the power is 0. So minus 3 plus 1. So this is the way we are going to perform additional of the polynomials. So next, our main objective, how we can able to perform by using the linked list. So this is our main objective, how we can able to perform the by using the linked list. So first we have to understand how we can represent it. So in case of linked list, there are number of nodes connected to each other. So in case of polynomial representation, nodes should have three components. First component is the coefficient. Second one is the exponent. Third one is the link to the address nodes. So this is the way we can able to represent the linked list. Next one, what is the algorithm? How we can perform? As we have to addition of two polynomials, so we require two linked list to represent the polynomial 1, polynomial 2. Then the summation we want to store in a separate link. So that's why first we have to create. So step 1, create a separate link list with two pointers. So two pointers, why we require two pointers? Required because first pointer points to the first node, second pointer points to the last node. So there are two pointers we require to store the result and value. To store the result and value, we require the two pointer. So second step, we have to traverse the both the linked list. So here we have to traverse the both the linked list until we are not reached the null. Null means end of the list. And after that, there is no data. And during the traversing, we have to compare the degree of both the nodes. If the both the nodes, here we are represent polynomial 1 for the first linked list, polynomial 2 is for the second linked list. Polynomial 1 is used to store the represent the polynomial 1, poly 2 is used to show the second polynomial. So whenever we compare, we have to compare the degree. If the degree of polynomial 1 and polynomial is 2 is same, then what we have to do? We have to create a new node in the resultant which coefficient value is sum of the polynomial 1 and polynomial 2 and degree is same. Because it is the same degree, another condition we have to check if the degree of polynomial 1 is greater than the polynomial 2. So if the polynomial degree is more than the polynomial 2, then we have to create a node in the resultant linked list, that is the summation of two polynomial, and we have to store the value of coefficient value of polynomial 1 as well as the degree polynomial 1. If the degree of polynomial 2 is greater than polynomial 1, then here the polynomial 2 is greater than, so we have to store the polynomial 2. How to store? We have to create a new node, store the coefficient of polynomial 2 as well as the degree is equal to the polynomial 2 and insert into the result. So this is very simple logic we have to follow for additional of the polynomial. Let us understand. So here this is the first polynomial is given to us. After that, we have to represent into the linked list. So this is the linked list representation of the polynomial. This one I have already covered in my previous video. I will put in my description section. You can go to that description section and understand how we create a linked list from a polynomial. So here, first, this is the coefficient. As I have already told, node consists of three things. First one is the coefficient. Second one is the exponent or power. So this is the exponent. This is the coefficient value is the 15. So coefficient is 15. Power is 3. So we store the power 3. So this is the start one. Here the start one is represent to polynomial first node. So the node address 100 is store the 100. Then next node. For the next term, that is the 7x square. 7 is the coefficient. Power is 2. Degree is 2. So after that, we store this value with link. Then third node. For the third term of the polynomial 5x. So this is 5 coefficient. This is the degree. This is the address. We store the address in the previous node and make the connection. Third one is the 10. So 10 is the coefficient. This is the exponent or degree. Degree is 0. Address is 400. We store the address in the previous node. And this is the last node which points to the last node of the linked list. So start one and last one is used to represent the first node and last nodes of polynomial first. So let's take another polynomial, that is 5x cube plus 10x plus 5. So similarly, we can represent the linked list. Here also, 2 pointer, start 2 and last 2. Start 1 is point, start 2 is point to the first node of the linked list. Last 2 point to the. So after that, we have to perform the addition. So how we are going to perform? So first we have to start from this first node and this last first. We have to compare with the degree. If the degree is same, then we have to perform here. This first element 5, sorry 3. So we have to store 3 and coefficient 15 plus 5 we are store the 20. Then we have to go to the next node. Next node, this is the 2, this is 1. So now polynomial, first polynomial degree is more. If degree is more, then we have to store the information. So 7, 2, here we store inside the resultant. Then this is the next node. So now this is the next node, this is the next node. So first, this is degree 1, this is degree 1. Whenever the degree is same, at that time we have to add the coefficient. So 5 plus 10, 15. Coefficient is, power is 50, coefficient is 15. Degree is 1, we store. Then we have to traverse to the next node. So this is the next node. So here 0, 0. Now degree is same. If degree is same, then we have to go for addition of the coefficient. 10 plus 5, 15. So this is the linked list representation. So this is our resultant polynomial. So this is the algorithm we have to follow for addition of the polynomial. So let us understand the language implementation. So here we are using the implementation in C language. As I have already told that we require 2 pointer, this 2 pointer, start one and last one we required for the polynomial 1. Then these 2 pointers we required for polynomial 2. These 2 pointers we required for the resultant. And all the pointer initialization is null. In between doing the program, we may require some pointers. That's why we declare the temp1, temp2, temp1, temp2. Generally, we are using to traverse the polynomial 1 and polynomial 2. In between, if any operation we are going to perform, for that we require temp. So this is the requirements. And the structure node consists of 3 things. First one is the coefficient, so integer coefficient. Second one is going to store the exponent value, so integer exponent. Third one is the link to the next node. That's why it is a point and pointer name is the next. So this is the algorithm we have to follow to create the node. So first we have to understand. So here what happened? Here we have to pass start, last, and coefficient value and exponent value. Means starting address we have to pass, as well as the last part we have to pass for the polynomial, as well as the coefficient and exponent value. Then we have to create. So whenever we call the function, at that time what happen? It will create a node. For example, we want to create the node for this value. So for this value we want to create. So as I have already told, initialization, that is the start. Here we are using for the start one, last one. So start one as well as the last one. Initialization value is null. So here we pass the null value. Null value coefficient is the 15 and exponent is the 3. So now here we are creating a node. So for example, the malloc function is used to create a node and it is successful. Here right now I am not writing any unsuccessful. We assume that the memory allocation is done successfully. When we create a node, at that time node has three parts. First one is for a coefficient, second one is for exponent, third one is for the link to the next node. So for store in which location? That is the temp. For example, right now temp store the value of 100. For example. Now temp coefficient the store the value of coefficient we pass. Here we pass 15. So we store the value 15. Then temp exponent, this part, store the value of 3. Then temp next equal to null. So it store the value of null right now. So it store the value of null. After that, it will check if start equal to last. Yes, start one right now, last one is equal to null, and start equal to null. Yes, it is true. If it is true, then this statement is going to execute. Means then the newly created node address stored inside the both last as well as the. So here what happened now? So now here 100 value store, here 100 value stored. So once it store the 100 value means now both the last node as well as the first node is point to the first node. Again we call for this node. Right now we are calling for this node. So for this node means we pass the 7 as well as the 2. So here we pass the value that is 100. Here also we pass the value 100. Here we pass the value that is 5. And here we pass the value 2. So what happened? Now temp store the newly allocated memory. So for example, this is the node is created with 3 component and the address is 200. Now temp is 200. Now temp points to this node. Now temp coefficient store the value of coefficient. What coefficient we pass? That is the 5. So it store the value of 5. Then temp exponent. So it store the value of 2. Then temp next store the value of null. So it store the value of null. Then if start equal to last, yes, it is true because start and last both are right now 100. If it is 100, then what we have to check? Last equal to null. Sorry, start equal to null. No, start equal to 100 means this loop. If condition is false, then it will go to the else part. Else means last next. That is last is 100, 100 next, 100 next. Right now store value, which value? Null. So we have to store which value? Temp, so that we can make the connection to this one. So here what happened? So now previously it stored the value of null. If store the value of null, then what we have to store? We have to store the 200 value. So here we have to store the 200 value. If I store the 200 value, then what happened? Now the link is connection is established. Then what happened? Last equal to temp. Reason is that previously last node points to the this one. Right now, this is the last node, so we have to make this connection. So last, so right, previously last node is this node. So last now store the value of 200. So if store the value of 200, now pointer points to this one. So again we call the function means 5x. So 5x means what happened? Now newly created node is created. So it stores the value of 5. This is the value is 1, then it is null. Then we have to make a connection and then we have to store here. For example, this newly created address is 300. Now I store the 300 at that time. This also state to, so now this points to this one, this points to this one. So it have to continue this one. So this is the same logic, how to insert an element into the last position. Let us understand how to perform the addition of two polynomials. So here we have to pass the both the pointer we have to pass. This is, for example, two polynomial is given. So this is the R is the name of the function. Here we have to pass two polynomial means this is the polynomial, two polynomial is given. So let us understand how to perform addition of two polynomials. So the function name is R. Here we are pass the parameters. What are the parameters we require? So this is first polynomial, this is the second polynomial. So this is start one, start two, last one, last two. So for addition of two polynomials, we require minimum two, minimum 4 pointer. So here this is, so this is for polynomial 1, this is for polynomial 2. So we are passing the value. Then we have to traverse from one node to another to reach the till node to compare whether the degree is same or not. If degree is same, we have to go for addition. Otherwise, we have to copy to the resultant. So for that traversing, we require another pointer or not. So for that, we require a temp pointer. So here we make a temp one. We store the address of 100. So to now temp 2. So this is temp 2 right now points to the first node because you stored the 500, that is the start to. So this temp 1 and temp 2, two pointers we require to traverse the linked list. Then while temp 1 not equal to null and temp 2 not equal to null, means we have to traverse until we are not reach the end location. End is the both the linked list name is the null. That's why we make the condition temp1 not equal to null as well as temp2 not equal to null. If the condition is true, then we have to stop, means our addition is over. Then in between we have to check if temp1 exponent means this value and this value. So if it is equal means degree is same. If the degree is same, so here right now it is same, then we have to create a node. So as we are already know how to create start 3, last 3, because we are going to store in a resultant. Then temp1 coefficient and then temp1 coefficient and temp2 coefficient we have to add. Here we have to perform addition of the coefficient and we store the temp1 exponent. So 15 plus 10 we have to add and pass this value. Then we have to pass the 3 value. So according to that the node is created. So for example, this is our newly created node. The address, for example, it is 50. So now the coefficient value is temp1 plus temp2, that is 15 plus 5, that is 20. Coefficient or degree is component is 3. This is the null value whenever we create. Then this is start 3, last 3. So whenever we perform addition, after that we have to move to the next node. Temp 1 also move to the temp next. Temp 2 also move to temp. That's why temp 1 equal to temp 1 next. Temp 2 also temp. Now pointer points to this node. Now pointer point to this node. So again, while condition is true because temp 1 is 200, temp 2 is 600. Both are not null. So if it is true, body will be execute. Now it will check. Temp 1 exponent, that is 3. 3 is equal to 1. No, false. If it is false, it will go to this one. Else if temp 1 exponent is greater than, temp 1 is 3 and this is 1. Yes, it is true. If it is true, then what happened? We have to create a node. We have to pass the start and last. Which value? Temp 1 coefficient, that is 3, 7 and 3. According to that, the node will be created. Now, whenever we call the function, create function, just we cover create function, how to create. So it will store the value, that is 7, 3. This is the null value. Then what happened? This null value is deleted. Now, this is, for example, the address is created is the 150. It store the 115 and make the now last we point to this. So this is the thing. Now temp1 equal to temp1 next. Here what happened? Only this pointer moves to the next node. This pointer is as it is, means temp pointer is same. So now again, while temp1 is 300, temp2 is 600. Both are, so this condition is true. So body will be execute temp1 exponent 1. Sorry, exponent is the 1 as well as the temp2 exponent, that is the 1. Both the power is 1. If it is 1, then what we have to do? We have to create a node. We have to pass start and last, means start value is 550 and last value is 150. We have to pass with the coefficient addition, means 5 plus 1. 15 we have to pass. 15 as than 10. So what happened? One node is created. You store the value 15, then 1, then this is the null. So now what happened? So now this is, for example, it is 250 address. So he store the 250, make the connection. Now last 3 pointer points to this one. Okay. After that, what happened? Both the pointer points to next node. So now this pointer points to this one. Now this pointer points to this node. Again, it will execute. Both are true because it is 500. This is 700. So temp1 exponent equal to temp2 exponent. Yes, this is 0, this is 0. If it is true, then what happened? We have to pass the value, address value, this value with the addition value, that is 10 plus 5. 10 plus 5 we have to pass here. Here we have to pass the 10 plus 5, 15. Here the coefficient. Here we have to pass the value address, that is the 500. Address is 250. We have to, because last pointer point to. Then what happened? One node is created. The node is created and it store the value, that is 15. This is 0. This is null. Then it will check last equal to null. No. So here you have to make the connection also. So what happened? Now the connection is going to be established. So for example, the newly created node address is 350. It store the 350. Make the connection. This is the last 3. Now last 3 pointer points to this one. After that, what happened? Temp equal to temp next. So temp equal to temp next means point to the null value. So this one is false. False means now the function operation is over and we are already got the resultant. So if it is resultant means, so what is the solution? 20 plus 15x plus 15. So this value we want to print. So linked list store this value. Next question, how to print this value? So this is our next objective, how to print the value. This is our display function. So whenever we are going to display any polynomial, we have to pass the two pointer. First pointer is the start pointer. Second one is the last pointer. Minimum two pointer we have to pass. Then only we can able to print the value as per the polynomial format. The way we can able to do. So here in this case, we have to pass the 50 and last pointer is 350. Pass the value. So if start equal to null, we have to print empty because nothing is to print. Otherwise, what happened? Temp. Here we are required a temporary pointer that points to the starting node. As we are already knowing the linked list that we cannot use the starting address of the node. We cannot manipulate it because we lost the information. So start. While temp equal to not null. Yes, it is true right now because temp stored the which value? 50. If it is 50, then what happened? Print a percent d, which value? Coefficient value. Percent d coefficient means we print the 20, then x, then the exponent operation, then percent d. Exponent means 3 we print. Then if temp is not equal to last, temp is 50, 50 is not equal to 350, then what we have to print? We have to print plus. Then ending curly bracket, then temp equal to temp next. Now temp points to the next. Then while temp is not equal to null, yes, because right now temp value is 150. If it is 150, then we have to make the percent d coefficient. Coefficient is the 7, then x, then exponent is 2. Now temp is 150. Initial value of temp was 50, then 150. So it is, right now it is 150. So it is not equal to last, that is the 350. If it is not 350, then what we have to do? We have to write down plus symbol. Then end, then temp equal to temp next. Temp next right now 250 because 150 next is 250. So now it points to this one. Then ending curly bracket, it go to the starting curly bracket. Temp is not equal to null. Yes, temp is 250. 250 is not equal to null. Then what happened? Percent d, temp coefficient 250 coefficient is 15, x, this symbol, then percent d exponent. That is the one. Then temp is not equal to last. Temp is 250. 250 is not equal to last. If it is true, then what happened? We have to make a plus symbol, then temp equal to 350. Temp equal to temp next is 250, next is 350. So it points to this node right now. So here ending curly bracket, temp not equal to null. Yes, it is true. If it is true, what we have to print? The coefficient value. Exponent is 0. So here nothing to print. So then we have to check if temp equal not equal to last. Temp is 350. Right now last is 350. It is true. Then we don't have to print the plus because this operation will not execute. Temp equal to temp next. 350 next is null. Now temp points to this null value. Ending curly bracket, temp is not equal to null. Yes, it is true. If it is true means we have to stop here. So right now we can able to print the summation of two polynomial or not. So this is the function we have to use for the polynomial one, polynomial addition. First function is for the how to create the polynomial, then how to print the polynomial, then how to display the polynomial after the addition. So after that, this is the, if we run the program, so this is the main function. In main function, we create the first polynomial. We have to for 15. So this is the way we have to pass the coefficient as well as the exponent value. Then we have to display the first node, first polynomial, then second polynomial. So addition of two polynomial, then what? So whenever we execute this much, output will be according to that. Then we are going to create the node. After that, we are printing the value. Then addition value. So this is the our addition. Let us go back to the our main that is the platform. So this is the same code here I have written. Same code. This is the display. Same thing. This is the addition. Same code here. Then we have to run the program. So this is our output. We are getting the. Here I have fixed to polynomial. If you want, you can change the polynomial here. You can modify the program, enter the coefficient value, enter the exponent value, then you scan and you enter, create the function, call it. So you can go for modification. This is only simple program. Do you understand how we are going to add to polynomial? So you can also do customize it also. So whenever we are implementing the addition of polynomial by using linked list, there are some advantages. So linked list can be handled polynomials of any degree because here memory allocation is dynamically, but which is not possible in case of array, because array we cannot go to the any degree. We cannot go because we are fixed how much a degree we can go for it. But in case of linked list, as per our requirements, we can increase the degree, or as per our degree, number of degrees, we can create the node. So this is the main advantage. So here what happened? We can easily handle the storage and retrieval coefficient and degree comparative to array. So this is the way, because it is dynamic, by help of the pointer we can able to access. So this is the advantage of implementation, and we can also perform recursively. We can also perform the polynomial addition by recursively. It can be possible to do it. So what are the advantages? So implementation is more complex than the array, because you are already know here we have to use the structure, number of pointers. So implementation using any programming language, it is very difficult. Here we are implementing the C language. It's also, so performance wise it is slow. Reason is that here we are storing more information, because here we are adding one extra information, that is the pointer to the next node. If we are adding extra information, so what happened whenever we go for computational, it the time consumption is more compared to the linked list. So thanks for watching my video. Hope you are able to understand the concept thoroughly.